In this video, I'm going to continue to look at the homework set. So let's see problem number 9 in section 3.2 homework set. So use the rational zero theorems to find all possible rational zeros for the polynomial functions. Okay, so then we need to use the formula, the possible rational zeros, which is the, give me a second. So possible rational zeros. This one, the formula is plus minus the factors of constant term, right? Divided by factors of leading coefficient. Okay, so the set of all the fractions are going to be the positive rational zeros. So in the problem number 9, this is 3.2, problem number 9. Okay, so the function m of x defined by 18x squared and the minus 24 x squared x cubed and then minus 24x squared plus 15 x minus 5. So 18 is a leading coefficient and the negative 5 is constant term, right? But here negative 5, we don't have to take care of the negative sign because eventually we're going to put plus minus sign. So then the factors of coefficient, leading coefficient, 18 going to be the 1 and then 2, the 3, right? Now 4 and 5, 6, right? And then 8 and then 18, right? 9. It's not 8. It should be 9. Okay. And then the factors of 5, which is factor of the constant term, is going to be just 1 and 5, right? Because 5 is the prime number. So then we got this plus minus what? 1 over 1, 1 over 2. Just remember that 1 over 1, because the top one from the factors of constant term, and then that one, the bottom one, comes from the factors of leading coefficient. So 1 over 1 and the plus minus 1 over 2 plus minus 1 over 3, and the plus minus 1 over 6 plus minus 1 over 9, the plus minus 1 over 18. Okay, and the plus minus 5 over 1, plus minus 5 over 2, the plus minus 5 over 3, plus minus 5 over 6, and the plus minus 5 over 9, plus minus 5 over 18. Okay, so then look at this. Plus my 1 over 1, this is 1, right? Then 5 over 1 is 5. All right, and then let's see. Then this is fine. I think that's the okay, that's the all of the. I mean, I'm just trying to find out pairs of number fractions which are eventually equal, but I don't see any pairs of numbers. All numbers are different in the set, so that should be our answer. Okay, so now next problems. Give me a second. The problem number 7. Here's a question: determine whether the given number is a zero or polynomial function following the number. So to figure out, you may know the easiest way to figure out the answer is just simply just plug in 1/2 into the x into the function. Okay, but let me use the factor theorems, which means that if h of x in this problem, the function h of x, we divide h of x by x minus 1/2. Okay, so then this is problem number 7. So h of x, we divide the h of x by x minus 1/2. Okay, using the order division or syntactic division. Then we're gonna get the quotient and the remainder right here. So once we divide h of x by x minus 1/2, and then if it turns out that the remainder is 0, becomes 0, then by factor theorems, x minus 1/2 must be a factor. So it means that the 1/2 must be 0, which means that 1/2 makes the h of x to be 0. Okay, so we'll see. So now then, let me use the syntactic division. Okay, so we'll just write down all the coefficient of function h of x. So 1. By the way, h of x is the x cubed plus 4x squared minus 7x plus 8. Okay, so then coefficient of, writing down, I'm going to write down all the coefficients of h of x, okay, in a row. So 1, 4, -7, and just keep in mind, there's one thing you should keep in mind, that if the there is one missing term. For example, if the second degree term is missing, even though that second term is missing, for example, you have to mention the coefficient, which is 0, when you do syntactic division. Okay, so now and then we just write down 1/2 here. So 1/2 is the what comes from the number making the divisor to be 0. Okay, so it's 1 and then 1/2. Okay, so adding them up, so 9/2. Okay, so C now is 9/2, and then 9/4. Okay, adding them up, so it's 19/4. Okay, then 19/8. Okay, so which is the 8 plus and 8 plus 19/8, right? So I don't think this is the answer. I mean, I don't think the 1/2 is must be a 1/2 is a 0. Okay, because remainder is not equal 0. Okay, so but I told you, if you got the 0 right there, it means that what, x minus 1/2 factor, it means that 1/2 must be a 0 of h of x. Okay, but so let's move to the next problems. All right, so problem number 7. Um, I found some mistake in my solution. So when I just divide the h of x by x minus 1/2 using syntactic division, so I missed the negative sign right there. So it should be negative, right? Not positive 19/4, but it should be negative 19/4. Okay. So then the 1/2 times negative 19/4, which is negative 19/8, and then adding them, adding 8 and 9 to negative 19/8, we're going to get 45/8. Still, the remainder is not 0. So 1/2 is not a 0. Okay. So now let's move to uh, the next problems. All right, so problem number 5. Okay, so h of x is defined by 2x to the fourth power plus x cubed minus x squared plus 3x plus 5. Define the function value h of -2 by using syntactic division. So how can I find out the function value without, simply just plugging -2 into the function? So you're going to use remainder theorems. Okay, so what remainder theorem is this? So in that problems number 5, so h of x is defined by 2x, to the fourth power plus x cubed minus x squared plus 3x plus 5. Now what I'm going to do, we're going to divide h of x by x plus 2. Okay, then we're going to get quotient, okay, and then plus remainder. So once we express h of x in terms of divisor, quotient, and the remainder, Then h of -2, we just evaluate h of x at -2 using that expression. Okay. Well, then you see when x is -2, x plus 2 is going to be 0. So 0 times quotient going to be 0, right? So remainder going to be left. So h of -2 turns out to be r. So that's the remaining theorems. So instead of the plugging -2 into the definition of function directly, we just rewrite h of x in terms of divisor, quotient, remainder. And then here, when you choose the divisor, we just construct the divisor. So the -2 gonna be 0. Okay. So normally in generalizers, f of x, we just express f of x as x minus c, the q of x, and then plus r. Then f of c gonna be r. Okay. So in these problems, c is what? -2. Okay. So it's -2. So then let me figure out the quotient remainder using synthetic division. Okay. So 2, 1. I'm just writing the coefficient of the polynomial function. Okay. 1, 2, 1, -1, and 3 and 5. Right. And then this is -2. Okay. So here's a 2, -4, -3, 6, 5, -10, 7. Okay. So -14. Okay. So which is what, -9, right? Okay. So the answer is, yeah, in this case, what? C. Okay. All right. So now, see, let's move to the section 3.1 homework set. Okay. All right. So let's see problem number 11, section 3.1 homework set. So in 3.1, we studied what? The quadratic function. So vertex form and vertex point. Starting from vertex point, we figured out the vertex form, and then axis of symmetry, and then the variable opens up and down, and the x-intercept, the maximum or minimum, increasing, decreasing, and then uh, we studied, we figured out how to solve the quadratic inequality using the graphing or test point. So in this problem is about what quadratic inequality. Okay, so let me solve the problem using the test point method. Okay, so now, okay, see problems. W squared minus 2w minus 3 is greater than or equals 0. So step 1, in you can solve this one by using graphical method or test point method, but yeah, I'm going to use test point method. Okay. In the test point method, the step 1 is to get 0 on one side. Okay. So it means, yeah, so but you can see that here in the problems, we already got 0 on the right hand side, so we skip step 1. Okay, now step 2, we'll find the x-intercept, or we can say root, or zeros. Okay, but I'm gonna just consider omega w squared minus 2w minus 3 as a function. Okay, so x-intercept, so of f of x defined by the left hand side of inequality. So w squared minus 2w minus 3. Okay. So, but here I told you the several times, x-intercept is nothing but what? The zeros. Okay. So that function. So f of x is function, but specifically this is a polynomial function, right? So if the type of function is polynomial, then the x value making the function to be 0 is called the zeros. Okay. So, but what about the other type of function that we can call that value, x value, making the function to be 0 as root? Okay. So then, so let me see. To find out this, then what? Since the what? This is the polynomial as quadratic polynomial, right? So I'm going to find out the solution of the quadratic equation associated with this, okay? Because that's going to be x-intercept of that function, okay? So x-intercept of function and then solution of quadratic function, they're really closely related each other, okay? Keep in mind this. So I'm going to solve this omega squared minus 2 omega minus 3 equals 0. So well, we have to solve that equation because x-intercept is what? Intersection point between the graph of f of x and the x-axis. It means that the x-intercept, y-intercept, x-intercept is just a point, which means that they consist of the x coordinate, y coordinate. And since x-intercept lies on the x-axis, it means the y coordinate must be 0. So all we have to do is to figure out the x coordinate corresponding to y coordinate 0. So I'm going to replace f of x by 0. Then that's going to be quadratic equation. So that's all we have to solve quadratic equation. So now then I'm going to use the quadratic formula. Then omega w is equal to minus b, which is 2 plus minus square root b squared minus 4ac. So 12, right? Divided by 2 times a, which is 2. So then this is equal to 1 plus minus what? The 2. Okay. So it's going to be square root of 16 over 2, right? Because I just the to break up the fraction as 2 over 2 plus minus square root of 16 over 2. But 2 over 2 is nothing but 1, so we got this. And the square root of 16 is what? 4, right? So we got 1 plus minus 2, which is what? 1 plus 2 and 1 minus 2, which is 3 and negative 1, right? 3 and negative 1. So 3 and negative 1 are solutions. Okay. So now then, step 3. So in the graphical method, we plot the graph of the f of x. Okay. But in test point method, we just draw the number line is negative infinity and the infinity, and then they plot the x-intercept on the number line. Is considering this is just x-axis. Okay, we can consider that number line as x-axis. It's a negative 1 and then 3. So that we divide the number line, which is actually x-axis, okay, into the 3 survey numbers: negative infinity to negative 1, negative 1 to 3, and the 3 to infinity. Okay, so and then we pick the test point for each survey numbers. Okay, so in this case, let's say there's a negative 2, here is a 0, and then here is I don't know, maybe just 4. Okay, and then we evaluate the function, this one, at each test point to figure out sign. Okay, so f of negative 2, f of 0, and then f of 4. Okay, so now then f of negative 2 must be see is greater than 0. Okay, f of 0 must be less than 0, and the f4 must be greater than 0. Okay, all right. So you can check this one using calculator. Okay, so the only thing you have to do is figure out the sign of function at each test point. Keep in mind this. So what are you going to do now? So I mean, what does that mean? F of negative is greater than 0. It means that not only at -2, but also every single number x value on that interval, their function value must be greater than 0. So it's positive. It's negative, and here's positive. Okay. So, but now we back to the inequality problems. We want to find out, you know, the solution set of that inequality, but we set the left-hand side as f of x. So solving that inequality is nothing but solving that inequality. F of x is greater than or equals 0. Okay. So which interval function value is greater than positive? Here and here, right? Okay. So but since there is an equal sign right there, so we know, and then we know the f of -1 is 0 and the f of 3 is 0. Why? Because -1 and 3 are what? X-intercept. So we gonna include the -1 and 3. So from -infinity to the -1, and then 3 to infinity, that's gonna be, I mean, union of two interval must be a solution set of that inequality. Okay, so the answer is what? So negative, the solution set is -infinity through the -1, close union, close interval 3 to infinity. Okay, so keep in mind this. So it makes sense, actually we know, we can figure out, the graph of f of x roughly. See that the leading equation 1, which is positive, so graph of f of x must be parabola opens up, and then we know that parabola should cross the two x-intercept, -1 and 3, right? So graph must be like this, like that. Okay, we know that, right? Okay. So now, now we see that from -infinity to the -1. So the function value is, see that since graph lies above the x-axis, so f of x must be positive, and then -3 to infinity, function value is positive 2. Okay. So just you can yeah, keep in mind test point method and the graphical method. You don't have to um, apply the two methods at the same time. Okay, just use one of them. Okay. Now we see the next problems. All right, so problem number 9. So here's a question. Identify, excuse me, identify the solution set to the quadratic inequality by inspecting the graph of y equals -x squared plus 2x plus 3 as shown to the right. So now you see the inequality right there. So first one, the first job you have to do is to get 0 on one side. Okay, normally in the right hand side. Okay, so then see here. Okay, so x squared minus 2x is less than or equals 3, right here. So and then let me copy the graph of the function y, given the problem y equals -x squared plus 2x plus 3. So the graph is like that. So here's a -1 is a 3. Okay, and then this is 3 right here. Okay, so then to get 0 on the right hand side, then we got this x squared minus 2x minus 3 is less than or equals 0. But the problem says that we use the graph of that function, but this is not is not equal to the left hand side of the inequality, right? So I'm gonna just I'm gonna just get 0 on the not right hand side but left hand side to get the function which from that inequality which is equal to that function. Okay, so so instead of that, I'm gonna subtract x squared and then -2x on both sides to get 0 on the left hand side. Then what are you gonna get? This here. So less than or equals negative x squared and then plus 2x. Okay. See, this should be plus right here. Okay. Just typo. Okay, plus 3. Okay. So instead of y, let me use f of x. Okay. So let's say instead of y, let me use f of x. Okay. So now then this is f of x, right? Okay. So then we want to find out what the solution set. What where f of x is greater than or equals 0. So we want to find a solution set where f of x is greater than or equals 0. Okay. So now, so we can figure out the interval on the x-axis where f of x is greater than or equals 0. See that from here, negative 1 through the what? 3, right? Through the 3. Because on that interval, the f of x, the graph of f of x is what? Lies above x-axis, which means that the f of x is greater than or equals 0. Okay, so the answer is what? Negative 1 through the solution set is negative 1 through the 3, the closing number. Why just put use the closing number instead of opening number? Because there is equal sign right here. Okay, so let's move to the next problems. All right, so problem number 6. Okay, so this question pretty much the problem asks you to find everything every information about the quadratic function. So domain and I think, yeah, so we see range of the quadratic function, maximum, minimum, and then interval where functions increasing, decreasing, right? So to figure out them, we need to find out vertex first. Okay, so finding vertex is really important. If you got wrong in vertex, then you're gonna get wrong in other information. So please make sure that you're gonna get the right vertex value. Okay, so y, let me use that f of x instead of y. Okay, is negative 2x squared plus 6x plus 1. Okay, so right here. Okay, this is problem number 6. Then the vertex is the h comma k, right? So here h is actually negative b over 2a. Okay, so b is 6 and the a is a negative 2, so we got 6 over 4, right? Which is 3/2. Okay, so then now then k is what? Gonna be f of 3/2. Okay, so let me figure out the f of 3/2 using calculator. Okay, so I just figured out f of 3/2, which is 5.5 right there. So now then, okay, let's find out then. So let's plot the graph of f of x roughly. I know you don't have to do, but to better understand, I'll just plot. I'm gonna plot the graph of f of x. So so let's say this is a vertex 3/2. It's 3/2 is nothing but 1.5. So you can say 1.5 instead of 3/2. Okay, it doesn't matter. 7.5. And then see the leading coefficient is negative. It means that the graph of this guy must be parabola opens down. Okay. So and then y-intercept must be 0.1. Okay. Right here. So this is 0.1. So graph must be like this. Like that. Okay. Sorry, this is kind of not quite accurate, but please understand that. So now that you can see the range gonna be what? Range gonna be from what? 5.5 through the, negative infinity through the 5.5, right? Okay, so here range gonna be negative infinity through the 5.5. Okay, and the close. All right, and the maximum minimum, yeah, so maximum, the function doesn't have minimum, right? Because the graph goes down to infinity, right? Okay, so then there is maximum, which is what? The y coordinate vertex. This is a vertex, okay? Okay, so now maximum going to be 5.5. Here, maximum, well, maximum value function, which means that maximum y value, okay? And the number over which function is increasing, decreasing? Yeah, see that from the negative infinity to the, here's a k, right? Here's h, x coordinate of vertex is 3/2, okay? From negative infinity to the 3/2, the graph is what? Is going up, right? So it's increasing. Okay, I told you when you read the graph, you have to read the graph from the left to the right because we are interested in a change of y value as x is increasing, not decreasing. Okay, so as x is increasing from negative infinity to the 3 graph is going up, which means that y value is increasing. That is called the that's what we say, that function is increasing. Okay, and then the from after the as we move across the 3/2, the what the function is going down, right? This is going, which means that f of x is decreasing. Okay, so we can say what f of x is increasing on what negative infinity to what 3/2 is actually 1.5, right? Okay, open, and then decreasing on 1.5 to infinity. Okay, so okay, like this. All right. So that's all about the section 3.1 and 3.2 homework set. Okay. So then let me stop here.